Hi everyone. So today let's think about this little question called construct binary tree from in-order and post-order traversal. Well, for in-order traversal, we'll first traverse the left, then the root and right. But for post-order traversal, we'll first traverse the left and then right and finally root. Okay, now let's dive in this example here. Maybe you should join. Okay, so for the in-order traversal, we will be traversing this 9 first and then go to this 3 and then go to this 15 because it's also a left node, and then go to this 20 and finally 7. So the traversal will be like this. Okay, now let's check the post order traversal with different color. You see the post order traversal here. We're starting at this 9, and then we'll go to the 15 because we prefer the nodes instead of root, and then we'll go to this 7 and go to this 20 and finally go to this 3. So this is the post-order traversal result. So this question has very similar strategy with the previous question, which we have the in-order and pre-order traversal. So our intuition is that we want to get the root from the post-order first. So you see the root 3 is actually the last element in post-order. We can easily pop it out. And then we plug in this 3 into in-order. So you see the 3 is here in in-order. And once we get 3 in order, we want to split the in-order array into the left subtree, which is 9, and the right subtree, which is 15, 20, and 7. And finally, we run recursion on the left subtree and right subtree will get the result. Okay, now let's dive into the coding part. So first, the first thing for this tree problem is to check whether the tree is null, right? So if the in order is null, we immediately return null. The next thing, let me copy paste from iteration to get root from the post order, and after that we use that roots in order to build the node. And finally, we check the right subtree and left subtree. Here we want to check the right subtree first because it's post order traversal. Okay, now finish coding comments. Let's write the coding part. If no in order, we immediately return null. And after that, we want to get the root value first from post order. So we recursively pop the last element from post order using this pop function. And we also want the root index. So we can check the left and right subtree. The root index we want to get from in order using this index function and pass root of L. And after that, we want to rebuild the tree node. So let's say the root node is using the tree node function and passing root of L. Okay, now finish node. Let's check the right and left subtree. So for the right subtree, just call the help function. So root of right is equal to this function, right? And for in order, we want to pass all the way from the mid to the all the way from root index to the end, right? And from the post order, we want to keep it at it. So it will keep popping the element. And root of left is similar to this one, so copy paste here. And we want to study all the way from beginning to root index. And finally, we want to return the root, and I think should be done. Okay, so let's meet the result if it works. Okay, so the time capacity, memory usage of this solution is not bad, and I think the coding part is very easy to understand. If you like this video, please subscribe to my channel, and see you next time. Thank you.